Yong. You can call me Warren. I'm the ESR number 1 for WaveComBE project. I'm currently the PhD student at University of Twente. Today, I'm going to share with you about my research project for my PhD study. My PhD research is about the millimeter wave antenna for massive MIMO outdoor base station. So when we're talking about 5G, we know that 5G have the ambition to get a very high throughput and low latency. This is because for 5G communication is no longer only the communication system, but we're also talking about other applications such as IoT, Internet of Things, or the things connected, and also the application for the medical. And that's why we need a connection with low latency and high speed. However, the current low frequency band, which is below the sub-6 GHz, are facing some issue, which is we are actually out of bandwidth, and most of the bandwidth is already occupied for other applications. Therefore, we need to move into the millimeter wave band. And this is the advantage of using a millimeter wave band. One is number of the bandwidth is not being licensed yet. However, going to the millimeter wave band, we have a lot of challenge. So this is the frequency band, the first millimeter wave band that have been proposed by the various countries. As for my project, our intention is to cover the bandwidth as wide as possible so that all the frequency band that used by all the other countries can be covered, and which is coming from 24.25 GHz to 29.5 GHz. However, to design an antenna in millimeter wave band, there are some challenges that need to be overcome. One is about the high propagation path loss in millimeter wave band. It experiences more attenuation such as rain attenuation and the oxygen attenuation. Therefore, more transmitter is required in order to ensure our antenna system is working properly. And we need more power amplifier, but this will be very expensive. The antenna system for the 5G outdoor base station can be divided into two parts. One is for front haul link, one is for back haul link. For front haul link, we need the antenna performance with the medium scan, but with wide scanning angle or wide beam coverage, which is considered as multi-beam system. Another application is on the back hauling. For back hauling antenna system, we need a high gain antenna system and also low side lobe level, and of course low cross polarization. The existing antenna for millimeter wave band are as follows. One of the most common type is the low-cost microstrip antenna. However, when we come into millimeter wave band, this microstrip antenna is experiencing high losses, and therefore we go into the alternative solution, which is LTCC. But the fabrication of the LTCC is very complicated, which is result in a high fabrication cost. Other solutions are waveguide slot antenna and substrate integrated waveguide antenna. So as a conclusion, as a short, small conclusion in this part, in the design of the millimeter wave band antenna, the transmission line playing a very crucial role. So we summarize that the existing transmission line that have been proposed for millimeter wave band are as follows. One is the conventional microstrip line, which is high loss but low cost. And another solution is SIW and LTCC, which is medium cost, and the loss is also medium. And the most favorite type is the waveguide slot antenna, but it results in a very high manufacturing cost. And therefore, we need some solution that fall in the region of low cost, low fabrication cost, and low loss, which is gap waveguide antenna. So my project is in the collaboration with GapWave in Sweden. And this project is funded by the European Union Marie Curie project, and the other partner from industry and university are as follows. For more information about my project, you can follow us at WaveComBE webpage or other social media website. Thank you.